Hi, I'm Nanda. I'm from Chennai. I'm part of ThoughtWorks today. I'm going to talk about history of test automation. Before getting to the talk, just want to know how many of you are QAs. Okay. Maybe half. How many do test automations? Okay. I think almost the same answer. So how many do test automation using other than Selenium? Okay, so what are the tools? Okay.
UFT code editing and the test company.
Okay. Advancing. Yeah. Okay. It's cool. There's a good collection of mix of tools. So my talk here is going to be mostly around how the evaluation of test automation, where it started, how the markets are reached, and what does the UFT has done, or the memory tools, what memory tools are done. How come the rise of the open source tools, and I'll slowly touch upon current trends and going forward. So agenda is going to look like something like this. So test automation, how it all started, initial automation and techniques, automation tools market, why COTS flourished, basically the commercial off-the-shelf tools like your Rational, your Test Complete, all those, how come it flourished, and what are the reasons for the rise of open source tools? You see a lot of Selenium and a lot of other tools. And what are other automation challenges other than the regular functional? Because most of the tools I heard was functional automation. What are the other challenges? What are the other areas to actually go and automate? And we'll currently look at current and going forward. So test automation, how it all started. It started when testing actually started. So once the development was done, what happened is releases were happening and testing were done by the developers themselves. And we all know that that's basically how the evaluation of testers happened. At some point, what happened was the testing time was taking more than the developers' time. So they were not able to release. So there was a huge time needed for release testing or regression testing. Those kind of time were actually taking a lot. So there were companies or product teams which were having more testers than the actual developers. So the efficiency of the testers decreased. The release time were actually taking a lot of time. So then came the problem of repeated tasks. So when a tester is actually doing a repeated task of doing a regression testing or release testing, it is prone to be error, as well as the fatigue factor actually affects them. Right? So they are not able to actually, they bored up, or the boredom actually comes to them. They are not actually able to look up the same screen. Assume you have been testing the same screen or same model for a couple of days. Actually, you tend to assume that I think their own bug exists. I want to just keep. That's a natural human tendency when they actually start doing a repeated task. Also, to improve accuracy. So when these fatigue happens, I think the accuracy or the test, the test results that actually comes out of the testers, actually the quality is very low. So need to improve accuracy was also there, and to increase test coverage. So how to test increase test coverage was so when you do an automation for a particular module or a set of test cases, you have in your hand a lot of other time, so that actually your existing test cases, you run your test automation. The other test actually you find new tests, you write new tests, you do an exploratory product of understand that how the users actually interact with the product. You come out with new testing scenarios. You get time to actually think through that, and your testing coverage increases. So, and there is one more question, like there are few tests which we can't do ourselves, like something like load testing, where you need 500 users, or concurrent testing, where 100 users are logged in, how your application behaves when 1,000 people are jamming a cinema booking site, or a hotel accommodation site, or a Christmas holiday booking offer sites, or e-commerce sites. Right? Those kind of scenarios, right? I mean, until you get into the production, you won't be able to actually get a feel of the real scenarios happening. So, I mean, when Flipkart launches comes with an offer, I mean, the $1 billion sale or on that particular day, what happens is I think most of the servers crashes. Right? So if at all you want to actually to reproduce those kind of simulate those kind of environments, I think that's not possible with manual testers. So that's where your need for automation actually increases. So here I'm going to touch upon how the initial automation and techniques look like. So when I say initial automation, right, so everything started with people actually, testers actually writing small batch scripts, small shell scripts, DOS prompt, DOS scripts, those kind of things to make the repetitive jobs automated fashion. And slowly what happened is, I think, there was a need for a record and playback kind of a tool. So that's where people felt, I'm doing a kind of a daily task or something. Let me record that somewhere. It could be in any form, right? When I say record and playback, it's not really the UI element that I'm actually touching upon. It could be even, I'm getting into a command prompt and typing a syntax. I don't want to have that. I want to go to the history or do a shortcut where I can actually reproduce the same effort and actually do a playback on it. So most of the initial automation were in the process of how I can record a manual sequence and how I can play it back. And most of the data were static data sets. There weren't enough tools to actually move your data sets separately out of your scripts. So today, most of the UFT or those things we're using, we'll use a data-driven kind of approach where we'll move our data to somewhere, Excel sheet, database, XML files, or whatnot, right? So, but the initial automation, they were actually, Dutch data were so much embedded in the scripts, and it was a static scripts. So if at all they want to actually do another set of static tests, they need to go and edit it manually, or they need to record it and play back again. Low tool maturity. Today, we have got a very good, I would say we have got in a very good environment where we can actually choose our tools and products, where you can have a plugin on top of it, where we can actually, if not there is any supporting library, we can write a supporting library. But those days, I think low tool maturity, because it was not open enough, you can't actually plug and play. And a lot of manual intervention. Something like, there were few areas of your same manual step which could not be automated. So you need to actually, your human intervention is needed. So you can't actually run your script for 10 hours, where there is a manual, a human has to come in and actually connect to a particular server or a network or a VPN, those kind of stuff were there. So manual intervention was there. No standard logging. So most of the tools, even I'm sure there's UFTs and other tools today, even like you can't actually plug into any of your Log4j or something like that. You want to have your own logging, you can actually use those logging tools integrated to it and make it comfortably. No parallel but distributed. So when the automation, test automation actually started, it was only an IDE or a single testing tool where you need to have all your scripts and just you need to play back or run the scripts. It runs on a single machine. Very rarely you had an agent concept where you can actually run on one agent. But even those cases, I think you need a license of that software where you need actually executing, running the software as well. So these are the limitations, or I would say this is how actually initial automation started with all these constraints, and it has slowly got matured. So what was happening, right? I think the software, actually, the software field was like, it's not like in 2000 or in late 1990s only these test automation tools actually started. Test automation, if you actually look back, even in 1980s, there were test automation tools which started actually happening in the market. So if you go back and look, right, it's almost like 20-25 years today. A test automation by itself practice or the tools or the market itself is a mature market, I would say, where it has gone to a lot of transformation from, owned by bigger enterprises like your HPs, your likes of IBMs, your likes of individual entrepreneurs. It has moved to a more open source world. But whereas if you look at late 1980s, that's where actually the market actually picked up, where the people felt there's a need for a commercial tool, right? So before that, most of the softwares actually were, most of the test automation were not in a, I would say, as a tool format or a commercial tool level where everybody can actually use such a tool. so each and every company or each and every software department or a product, they have their own set of record and playback scripts which will actually do a user simulation. That's what they do. They run before going for a release. But in 1985, everything changed. I would say Auto Tester was the first commercial test tool for PC. It was basically for, I mean, it was 1985, so naturally it was MS-DOS world. So Autodesk was our first commercial tool. Then in 1980, late 1980s, Seed software. How many of you know Silk Test? Heard of Silk Test? Okay. Okay. So a tool called Silk Test evolved. So actually, it was developed by Seed software in 1988. That was the first release for them. Then, if you go and see Seed, I don't think you will be able to find that name because Seed sold the Silk Test software to Borland, and then Borland it Micro Focus. Oh. So 1980s, 90s, 95s, 2000s were actually ruled by Silk Test, I would say, because there are a lot of advantage of Silk Test. They're supporting a language called VodQA language, which is like C, a little bit of improved C, I would say, a little bit of object supporting for, little bit of C++ with object supports. But all these tools, if you actually look at, they were customized by their own company because they felt that the testers are not in a mature state where they can actually go and write your own C++ program or Java programs or something like that. So what they made is they customized a software on top of all those libraries to make it look like a little bit a newer languages. That's called VodQA language. All those, scripting languages for a particular tool evolved. And in 1989, it was LoadRunner from the Mercury Interactive. Mercury was bought by HP at some point of time. That's when QTP was very popular. It became Mercury tool was bought by HP. And Mercury Interactive launched a Windrunner in 1995. So Windrunner, I would say, is a father of QTP. The reason being, Windrunner and QTP exist in the same era, where QTP was actually taking over the market, and actually, in fact, it was stealing the Windrunner's market. Windrunner I would say, Windrunner was one of the finest test automation tool in 2000s. Where it was able to automate both your client-server applications and web-based applications. And it was supporting a language called C-like scripting. They add their own scripting language. Language is called TestScript language. It is mostly like a C syntax with no object supports. So you need to write scripts, a lot of scripts. You can write in header files or something like that, which you can HP product. It's almost like 25, 27 years old product that you're actually working, sitting on. So Quick Test actually, Quick Test Professional, when Mercury had, they felt that C-like syntax, it was a bit outdated. They were not able to actually, it was in fact commercially not viable for them to actually write plugins for newly third-party supported libraries like .NET or Java or your DevX controls or infra-logistics, any rich interface, client interface. So your Flash or those kind of things, they were struggling to support using Windrunner because they need to write C libraries. So what they planned is they came out with a Quick Test Professional, which with .NET support and which was written in VB script, which was actually connected in VB script by in fact call other DLLs or something like that to do another operations. So Quick Test Professional was a big hit in the market. That's when HP actually took over both with test and killed Devendra. Automated QA launched Test Complete in 2000. So somebody raised ads, right? So it was initially Test Complete was for automated QA, and then it was merged with Smart Beer. And they know that this Smart Beer has QA Complete, another set of tools. So in this, if you actually look at right, so the whole of the commercial tool market was happening in 1985 to end of 2000s, or I would say it extended to a few places until 2005. Because those enterprises which have bought a 10-year license or 5-year licenses signed at 2000 or the initial 2005 are still using it in 2010s and 2012s. So that's how we actually look like. And Selenium developed, I thought, of 2004, and and it has taken. I mean, recently last year we actually celebrated 10 years of Selenium. So there are other tools like Rational, Ranorex, CompuWare, OpenSTA, White, and AutoIT. And the list is actually huge. But we are actually trying to understand here how from 1985 most of the tools. I'm not actually going to try all those other tools actually that came after 2004, which are more open source and which is more popular with you guys. Rational Robo. So Rational was one of the software company. His founder was someone called Delvin, who was an entrepreneur, who was actually having this Rational software. He sold to IBM. IBM at a very mature state when the Rational had different product suites to it. Rational had a Rational Robo, Rational Rose, Rational Clearcase. It's a suite of product which actually IBM took over. So if you actually see, right, I think when these players actually Seed was there, Mercury was there, Automated QA was there, Rational was there, they were actually pioneers in actually this kind of commercial tool, and slowly moved to the enterprises level people actually, and the whole testing tool itself took a different transformation with the cost increase. So Rational Robo became your Rational functional tester of IBM's functional tester. So, and CompuWare is a UK-based company which has a product called Test Partner. Ranorex is another tool. OpenSTA became around 2005. There was White for something like a Selenium, where you can automate web. White, you can automate desktop applications, and AutoIT, it's another open source. So you look at why commercial off-the-shelf tools flourished, right? I think we are not able to actually, I mean, even though these things actually came almost like 85, now we are in 2015, almost like 15, 20, 30 years, still I think we have an effect, I would say, on those tools because those were actually record and playback, right? Those commercial off-the-shelf actually gave you a record and playback option. Even though it was very flakiness, I mean, you can't trust it. No ways a non-tech users or business users felt, I think I'm able to simulate something, right? Within a minute, within a 5-minute span, actually I'm able to record my whole business scenario and I'm able to run it back. So they felt, I think, they felt very comfortable. And object identification repository. So these people actually came out with a nice set of tools like QDP, called GuideSpy, those kind of an object repositories where you can actually identify an object and actually store it as well, so that it will be used for automation. So those things actually, like before these commercial off-the-shelf tools, the testers were not actually comfortable in actually getting understanding how can code look like, or what's inside a text box, or what is it called, a property. They were not much comfortable because they never have seen. But these GuideSpys and these kind of object repositories gave a little exposure to them of insights of what the forms they were filling up and the workflows they were actually making. So it helped them. They were able to interact more. They felt there is a connect between those kind of tools with the application they actually test day in, day out. Third-party tool support. So when I say third-party tool support, it's more about your rich internet applications. Right? So in the late 1990s or even mid of 2000, I think you have many rich internet applications. Like your Flash was there, your Flex was there, and your Silverlight component for Microsoft was there. So all these components, what they were doing is they were able to the same web UI, if you look in 2000s or in late 2000, there's a huge transformation, right? You're able to say kind of Web 2.0 kind of a UI, rich JavaScript, rich HTML, CS is actually playing around. So all those things were able to come out with third-party tools which developers were actually using. But these commercial, off-the-shelf providers actually made a tie-up with them, or they were able to allocate specific engineers to work on these products and come out with a plug-and-play model for them. So that's where QTP starts supporting Flex and your other tools, Flex and infra-district components, other we were able to actually directly support. And out-of-box support with test management tool, QTP had an integration with QC. So there are, I think they are able to come out with think about a plugin model where you can actually move your QTP to any standard test management tool or a defect management tool. You can actually come out with the plugins. Built-in schedulers. So even scheduling, I mean, you never had CA those days where you can actually schedule continuously integrating builds on up there. So testers, what they felt is, I mean, these commercial tools actually built in schedulers for them, so where they can actually run them, where they can actually put a timing on it and run at a particular point of time. And it supported both thick client and thin client. Even Selenium, right? I think it doesn't support thick client. So there were in early 2000 where client server applications still existed. Even today it exists, but there are more numbers in 2000, early 2000s. So at the point of time, if you look back, they felt I think one tool from a commercial will actually solve both of my purpose. And they are inbuilt exception handling and recovery scenarios. You can actually, rather than you writing a customized build, I mean, test execution reports, actually, they provide their own test execution reports. And rise of open source tools. So even though I think, even though we can say I think it was all evil and devil for the commercial of the self tools to actually to think, I mean, make only 15 to 20 years market with all those commercial products, but it laid a very good layout of what actually it actually took the testers close to an automation tool, right? I mean, today if you want to actually connect to a test automation tool, people are able to quickly connect to a QTP or something like that. Reason because of all those advantages came out, and slowly they have started seeing advantages in Selenium or these kind of open source tools because of the language support. You can actually write scripts in Java, in .NET. Initially, it was you were actually writing in a little something like a TSL or a Fortest language, which was customized version. But this language support actually gave a more open world to us, right? Where you can actually write your own objects, programming support directly to Java and .NET, Ruby and other direct support basically. And it has a lot of flexibility and it's more customizable. Integration with build tools, cost, no absolute cost, low risk, access to everyone, and also it has got vibrant community support. So there are many tools. We will example like JMeter, which is there for almost like 25 years. Your Gatling, your Scala test, your Cucumber, any open source tools. You see, I mean, all these. That's the reason for actually. These are the reason for all these tools to exist in this market for this long time. I will touch upon other automation challenges, right? So when we're talking about all this test automation, it was predominantly mostly functional, and there were so once most of the functional problems are solved either by the commercial tool or by the open source tool, people have started looking at other challenges like how we can actually do a performance test, how we can do a UI test, how you can do mobile test. So there were. So that's when actually started focus changed towards other automation tools for different aspects like performance, load runner, your JMeter, your Gatling, service test. So initially everybody knows it was a 2-tier architecture, then a 3-tier architecture came where you have a middle tier or your service layer. So tests have been started at different levels basically. One is at a UI test separately, your service test and your database test. So that's when the service testing become popular. SOAP UI. Initially, SOAP UI is open source. Then it actually, I think the one version still remains open source. Another being tied up with the automated QA or the smart QA. And there's a Postman, rest assurance. There are multiple tools. Something like hermetic UI testing, where you can actually fake your. The UI need not hit the your service to actually to get your database back, where you can actually fake it and actually put the data to test your UI separately. Espresso, one nice tool. There are mobile testing, C-test, Robotium, Appium, Calabash. So all these other challenges, right, like performance, service, or your hermetic UI or mobile testing, these tools evolved to actually solve different problems at different point of time. So current and going forward. So if you actually look at a data space, your big data space or your analytical space or your ETL space or your visualization. So now what happens is your ETL jobs are run separately. Your data is analytical models are run somewhere, and your visualization is happening at a different layer. So there are three teams, or three different teams working on three different things, and they integrate, and you need to test. So how do you test a big data? There are a few tools, but not much mature tools. For ETL testing, there's an ICD-Q, and for if you look at each and every, there is a big data whole thing happening, your Spark thing for data orchestration. How do you actually go and solve those kind of challenges is what actually the current need. And Google is working a lot on web components and polymers, those kind of tools for visualization. How we can actually automate those kind of rich UI new components that's coming in. One way it could be using your open source like Sifuli or your other visualization tools you can go and solve. It's on distributed about cloud testing. So most of the commercial, even though we have been using multiple agents to actually perform tests and execute tests. Still, I think there's a lot of more space in the distributed and cloud testing that needs to be used. If not for if the infrastructure is a constraint or expertise to run is a constraint, there are there are commercial tools like Sauce Labs or Blitz to do your distributed or cloud testing. Multiple devices based sync testing. So how do you sync it? Today, people use multiple product or an app in multiple. You have a web client, you have a client, you have a mobile app, everything is there. So how do you actually do a sync testing on all these things? Are there any automation tools? Model-based testing. So rather than actually writing test automation for your software code, can we actually generate tests from the models itself? So there are research happening in there, and there are few tools like GuideTar, PyModel, and GraphWalker, which actually gives you all the combination of test cases that can be automated or test against these kind of models. Property-based testing. More infrastructure automation. When I say more infrastructure automation, it's like today we are actually solving all the functionally problems like from the tests, basically automating into that. What happens to your infrastructure basically? Who sets your environment, right? So today we have auto deployment, those stuff are taking care, but that's mostly for the production level or for the deployment purpose. But are we as testers already there to where you can use the AWS, Terraform, or a Docker to actually run our test? So basically, you write your test, you build your own Docker container, and you run your test in AWS. So there is no need for anybody to dependency. You set up your own product, test box, each and every one have your own Docker instance set up, run, and actually point your and run it. So those are the more we need to look at other infrastructure automations. That brings any questions?
Docker.
Yeah.
What is how we can be more efficient?
Okay. Okay. So he's asking what is Docker and okay, how we can actually Silva, no? Okay. What's up with Docker?
So Docker, right? So your test would be running from a machine. Then you have your scripts, right? So in case if you want to run this from a Docker container, so you make the test independent of any other different dependencies. For example, if you want Ruby or if you want Selenium along with Ruby, so you can put that in a container. Okay, build an image, bring up the container, and run tests from there. So it will not depend on any other machine which has either Ruby or Selenium installed. So this can be run on any machine which has just the Docker setup. You need not depend on any other environment. The container or the image will contain both. It will contain all the dependencies which are required for the test.
Okay.
Store into different machines.
Yes, you can use the same image, bring up the container in whichever server or whichever agent you wanted, and then run the test from there.
It's more about the virtualization. So assume you want to assume there are 4 different systems running in your application. One is running in Apache, and another is running a different application server. And each and every, all these 4 systems are differently running. You want to test that. What you are doing is actually creating a Docker container for each and every system in your local machine, where you can actually communicate and work on. So these Docker machines can be brought up with these scripts whenever needed. That's a Terraform. There are Terraform scripts which can actually on top of Docker, which actually makes your system up. 4 different systems can be in your own, Mac box or Windows box, all those kind of things. You can actually bring all those and you can actually test accordingly. As if you are doing a testing in a 4 system environment.
Have you heard of VMs test running on VMs?
Virtual machines.
Like Oracle VirtualBox?
Yes.
Yes.
Similar to that.
It's similar to that, but this has more advantage in the sense you need not allocate any resource as such. For example, in case of VMs, you would be allocating this many amount of memory, but Docker is not that case. So you have this image where you build what are the dependencies, what are the requirements for the tests to run, and they would be built and run whenever is needed. So if you want to run the test, you bring up the container and run. It will use the resources only when needed. Okay, but in case of VM, it is not the other way. You would allocate the resources for the tests as such. So when the tests are not run, the resources are idle. You can avoid this in Docker.
One more thing is software as a code concept is more involved, tied up with Docker. When I say that, I think for one of our production machines, you want a particular Unix instance with a particular database installed, with particular Jemo server or something like installed, other dependency software installed. All those things could be a part of your script. So you run the script, or this scripts run as part of your Docker, and your image is ready in your local machine. Yes, you can copy it.
Is there any linking between the Docker? Since I am adding a new dependency Docker, will it be reflected with any linking between that? Or else I need to make another copy.
You need not make a copy. You have to put that in the Docker file. So Docker file would contain what are the dependencies or what are the requirements for the test run. For example, if you have some other library or any plugin that you want to install in the image or in the container, you would add that in the Docker file. So once you build that, it will bring up or build the image with the newly added library. So now your Docker image is ready. And now you have to build the container. Yes. You need not copy. You have to just add and build it.
Okay, because you have a script, Docker file for that, you actually run this Docker file anywhere, you get the container.
Consider a simple example. See, you cannot have IE8 and see you want to test in IE8, 9, and 10 and 11. You cannot have a different multiple versions of IE in the same machine. Right? So you can, when you Dockerize your testing environment, with one unit you need Java, Selenium, and IE for you to run your system. So you have one container with Java, Selenium, IE8. Have another Docker image with IE Java, IE9, the same. So when you want to run your tests in IE8, you just spin up that container. And when you want the other time, only when you're running the test, the container will be active. Rest of the time, it doesn't consume any space. So in a single machine, single testing environment, you'll be able to have these many versions. Otherwise, you need to have a single machine for IE9, single machine for IE8. So this solves this problem. So you need not, you will have browser stacks and other things for that, but they are extremely costly. So with a single machine, say you have a Mac or Linux book, you can have these many number of OS features.
And the containers there when you run the test.
Thank you. So now we have
So I think people are distributing stickies. So please write the feedback for the session and for the speaker.
the